Welcome to this video on single-layer perceptrons. Today, we will explore their foundational role in neural network classification. Let's begin with an overview of what we will cover in this presentation. First, we will examine the fundamental components and architecture of perceptrons. Then, we will understand how perceptrons perform binary classification. Next, we will explore the role of bias terms and activation functions. We will also learn the process of training perceptron models. Finally, we will implement perceptrons using scikit-learn for real-world applications. A single-layer perceptron is a neural network designed for binary classification tasks. It classifies data into one of two classes using a single layer of connections between input and output. The 5 key components of a perceptron or inputs: weights, the weighted sum, the activation function, and the final output. Binary classification with perceptrons relies on creating a hyperplane in the input space. The hyperplane divides the space into two distinct regions, one for each class. Points above or on the hyperplane belong to class 1, while points below it belong to class 0. This mechanism is mathematically represented as the weighted sum of inputs. The decision boundary is defined by the equation w1x1 plus w2x2 plus ... plus wnxn equals 0. Bias terms play a crucial role in perceptrons by improving their flexibility. Bias shifts the decision boundary and acts as an additional input feature. It is implemented as a constant input, denoted as x0 equals 1, with its own weight, represented as w0 or b. The modified weighted sum equation becomes the sum of I equals 1 to I equals n of wixi plus b. Activation functions determine the perceptron's output based on the weighted sum. The unit step function is the most common activation function used in perceptrons. Its mathematical definition states that f z equals 1 if z is greater than or equal to 0 and f z equals 0 if z less than 0. Here, z represents the weighted sum of inputs plus the bias term. The training process for perceptrons involves iterative updates to the weights. First, weights are initialized. Then, the perceptron iterates through the training data and updates weights based on errors. This process repeats for a specified number of epochs. The weight update rule is wi new equals wi old plus r times y minus y hat times xi, where r is the learning rate, y is the actual class, and y hat is the predicted class. Implementing perceptrons in Python is straightforward using scikit-learn. The provided code snippet demonstrates how to create and train a perceptron model using the perceptron class. It also shows how to access the learned weights and bias after training. This makes perceptron implementation accessible and efficient for practical applications. To summarize, single-layer perceptrons are fundamental tools for binary classification tasks. Their key components include inputs, weights, the weighted sum, activation functions, and outputs. Bias terms enhance model flexibility by shifting decision boundaries. Training involves iterative weight updates to minimize classification errors. Scikit-learn simplifies perceptron implementation and forms the foundation for more complex neural networks. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.